So let's look now at how we might arrange this so that the for each loop is applied only to some of the primitives in our grid and not to others. Well, the first thing to do is to go back to our grid, and I'm going to select that. Press W to go into wireframe mode. Press S to select, for to select primitives, and let's just randomly select a few of these primitives. And then Tab, Group Geometry. Let's press L to rearrange our network view. So we've created a group which is these primitives here. I'm going to call it for group, and I'm going to call it $OS so that the group name is also for group, and we should see that we have 4 primitives in for group. The ForEach SOP doesn't have a group parameter, so we can't just run the ForEach SOP directly on certain primitives and not on others. We could use the group parameter of the partition SOP to ensure that we only create these face groups for the primitives that we've just selected. And let's see what we do. Let's see what happens when we do that. So we select for group as our group, and we see that we do indeed get balconies on these 4 primitives, but the other primitives disappear, which is not necessarily what we want. So there is another way of achieving this. Let's get rid of this group in our partition, which is to use a blast SOP. And let's move these up so we've got room for a blast SOP. A blast SOP is just a SOP which deletes geometry, and I'm going to select the group of primitives that we have created, and I'm going to delete non-selected. That gives us just the primitives that we selected, and these are passed through to the for each loop, and we got a balcony on each of these. And then if we click off to the side here, we can copy and then paste. The shortcut for that is Control-C, Control-V. Copy and paste this blast node, and change the delete non-selected box to delete selected, and that will give us all of the primitives apart from these ones that we'd selected. And then if we lay down a merge, we can merge together the output of the for each SOP with the other primitives, and we get the complete grid with balconies on the primitives that we selected. And probably for completeness you would want to add a fuse SOP to make sure that the points here were fused together. Let's look at a slightly more complicated example. I'm going to lay down a box, and I'm going to lay down another grid, and we'll give it a row and columns of 5, and then I'm going to copy the box onto each point of the grid, like so. And there we have an array of boxes. What I want to do is apply our balcony operation to one face of each of these boxes. So let's just isolate the box and have a look at it. And I want to check the the primitive numbers for the faces. And we can see that this face here, that's nearest to us, has a primitive number of 2. Let's remember that. Now in order to work, we're going to need to use a partition SOP to create groups, except in this case we're going to want one group for each cube rather than for each face of each cube. So we need to do a preliminary step, which is to use a connectivity SOP. And what a connectivity SOP does is create an attribute either at the point level or the primitive level, which is the same where, in this case, primitives are connected to each other. So in this case we would find that all of the primitives or faces of this cube here would have the same value for the attribute class as all of the other primitives or faces on this cube, and that value would be different from the value on this cube and that cube and that cube, and so on. And we can therefore use a partition SOP to create groups cube $class, because by default the local variable that's created here has the same name as the attribute, so we can use $class. And we should find, there we are, that it's creating a group for each cube, and that we have 6 primitives, 6 faces of the cube, in each group. So far so good. So let's disconnect, let's delete this stuff at the end here, and let's connect this into our ForEach SOP. Now what will happen to start with is that we need to change our group mask to cube, is that we'll find that it's creating a balcony on each face, which is not necessarily what we want. So one way to approach this is to start our SOP network here by just selecting a single face, which is just selecting a single face by using a blast, and the face that we were looking at earlier was face number 2, or primitive number 2, and we delete non-selected, and that should give us a single primitive going into this network for each cube, and that produces a balcony going downwards. But that's not exactly what we want. For a start, it's orientated in the wrong way, and secondly, the rest of the cube is missing. So we need to use the trick that we used earlier. Copy this, paste it, then delete the selected, and finish off with a merge, yeah, to bring this together. Now we have our balcony, but it doesn't really appear to be on the right face, so let's try a different face. Let's try using face number 3, for example. And that's going in there. Well, let's reverse the direction of our final poly extrude and make it positive. And then we should finally get a balcony on the front of each of these cubes, like so. Now let's look at a slightly different way of achieving exactly the same thing. I'm going to get rid of my partition SOP, and I'm going to use the ForEach SOP in its second incarnation, which is each attribute value. So let's select that, and the attribute value I'm going to use is class. So what this should do, and we can see it's already worked, is divide the primitives coming in to our ForEach SOP according to the value of the attribute class. It then groups them automatically into groups which have the same value of class within a tolerance which is set here. So what that's doing is creating groups of primitives with the same class, and then this each SOP down here is in fact deleting all of the primitives which don't have the value of class that we happen to be looking at in this iteration of the ForEach SOP. So this is iterating over the nodes inside once for each different value of class, and for each iteration it's only processing those primitives which have the value of class that we're dealing with in that particular iteration. So the first time round it will select a value of class of 0, and only those primitives with a class value of 0 will be operated on by the ForEach loop.